We are going to be talking about Chapter 8, Techniques of Integration. Basic integration formulas are given here. A integral of a constant is kx plus c. Integral x to the n is power rule x to the n plus 1 over n plus 1 plus c. Here be careful, n is not negative 1. Whenever n is negative 1, this is 1 over x, which is this actually. Integral dx over x is equal to ln absolute value x plus c. Integral exponential function e to the x is e to the x plus c. Integral a to the x dx is equal to a to the x over natural log of a plus c. Here we assume a positive and a is not 1. Integral sine x is negative cosine x plus c. Integral cosine is sine x plus c. Integral secant squared x is tangent x plus c. Integral cosecant squared x dx is negative cotangent x plus c. Integral secant x tangent x is equal to secant x plus c. Integral cosecant x cotangent x dx is equal to negative cosecant x plus c. Integral tangent x is natural log of absolute value of secant x plus c. Integral cotangent x is natural sine x, absolute value, don't forget that, plus c. Integral secant x is a natural log of absolute value of secant plus tangent x plus c. Integral cosecant x dx is negative natural log absolute value of cosecant x plus cotangent x plus c. 16 and 17 we didn't cover. This is arc sine. Integral dx square root of a squared minus x squared is arc sine x over a plus c. Integral dx a squared plus x squared is equal to 1 over a arc tangent x over a plus c. This 20, 21, 22, you don't need it actually, these are too much. Next we are going to see integration by parts. Excuse me. Integration by parts formula. Integral u of x v prime x dx is uv minus integral v u prime d dx. This comes from differentiation formula actually. And this is easier to remember. Okay. Integral u times dv is equal to uv minus v times du. For definite integrals, it's going to be the same. You just put limit points, and you have to evaluate here, and you have to evaluate here. This is integration by parts. 0 to 4 integral x e to the negative x. What you're going to do, you are going to let x to be u, e to the negative x dx to be dv, and dx is going to be du, and negative e to the x dx is equal to dv, and then you're going to go back to here, you're going to put everything in here, and you get a result. So I'm going to solve some more problems on that. It's going to give you the area between 0 to 4. We have to practice integration by parts. In my just a sec, maybe I can solve some problems from my previous class. One moment. Okay, so there are some examples that we did in fall 2019, and I want to go over them here. Integration by parts. This recalls what it was. Integral f of x g prime x dx is equal to f times g minus integral g times f prime x dx, f prime x dx. This formula comes from the product rule, differentiation, as I told you before. If you take the derivative of this, you get that. You integrate both sides, When you integrate this, you get f times g left, integral f times g prime plus f prime, integral f prime times g. So this is like integral u dv u v du, like this is v, this is du, okay? So it comes from differentiation rule, differentiation product rule for the the product rule for differentiation, okay? So there are 4 questions here. We are gonna go through. I'm gonna do one by one. Integral x sine x. The key here is choosing u and v properly. I want to choose first u, and I say it's first try because I might be wrong. Sometimes it doesn't work, so I just say first tries, but usually in your first try you're gonna get it right. Let u to be x, because if you solve more questions, you're gonna train yourself to choose the correct choice, okay? That's given. U is equal to x, du is equal to dx, and the rest is dv. Sine x dx is dv. From here, antiderivative is v is equal to negative cosine. Then we put it in the integration by parts formula. U is x, v is negative cosine, minus v is negative cosine, dx. Du is dx. We put everything in, and then minus makes plus negative x cosine x plus integral cosine x dx. Then integral x sine x dx is equal to negative x cosine x plus antiderivative is sine x plus c. So we got it. So we were right, our choice was right. If we had tried the other way around, if we said u is equal to sine x and dv x dx, then we would be in trouble, because we would just v would get like x squared, and this would make it more complex, and complex you wouldn't, more complicated. In this case, u and dv chosen ones are not right. So be careful to choose the correct one. Okay, next example is ln x dx integral. Our choice is u to be ln x and dx is dv. Let's see whether it's the right choice. Du is equal to 1 over x dx, dv is equal to x from here. Okay, and then we put this is integral ln x dx is equal to u times v minus integral v times du. V is x, u is what? U is ln x times x minus x times du is 1 over x dx. X's are gonna cancel each other. you see, as long as you get this integral simplified, then you are on the right track. X ln x minus 1 dx, x ln x minus x plus c. And then this is our final answer. We factored out x, that's fine. If you didn't do it, then no problem. I mean, it would be okay too. You don't have to if you don't want to. Okay, and example 3, our first guess is let u to be t squared, because I want the degree of t squared to reduce, because I don't like when the degree of t squared increases. Therefore, I preferred this to be u, so that the degree is going to decrease. And then e to the t dt is dv. And if you know that e to the t, the derivative is e to the t, antiderivative is e to the t. So this is the best choice to choose it to be dv because of that. The integral I, which is integral t squared e to the t dt, is equal to u times v minus v times du. This is the integration by parts, as you know. And what is u? U is t squared. What is v? Okay, if u is t squared, then du is easily 2t dt. If dv, what's our next box? Next box is about dv. E to the t dt is equal to dv, then v is equal to e to the t. Perfect. So u is t squared, v is e to the t, minus integral v is e to the t, du is 2t dt. We call this j because we have to apply integration by parts to it again. So far we found integral I, that was the question, it's equal to t squared e to the t minus j, which is, we have to work on this j again. So I take this j and work on it. J is equal to e to the t times 2t dt. I want to let 2t to be u and e to the t dt, again dv. This is equal to u times v minus v du. My goal is to reduce the degree of t, and that's the only way. From here, du is equal to 2 times dt, and dv is equal to e to the t dt. From here, v is equal to e to the t. Now I have u, v, du, everything I need. I put them in here. U is 2t, v is e to the t minus e to the t times du is 2 dt. And then this part is okay. This part, antiderivative is e to the t, and this is the final answer. Now I found my j, so I'm going to go back and write it in. I is equal to t squared e to the t minus j. T squared e to the t minus what j is, I'm going to put it in here. If there are any simplifications, I simplify. It seems there is none. Take out e to the t, which is a common factor in all. See, e to the t in all. Then t squared minus 2t plus minus makes plus 2 plus a big C, and this is our final answer. My next example is e to the x times sine x times dx. Now I have to figure out which one I should let u to be. Okay? So be careful, e to the x has antiderivative itself and its derivative itself, so it's always the best to choose e to the x as dv, e to the x dx as dv, okay? It's a good choice, it's the best choice actually. Then the rest is u. So u is sine x, du is cosine x, e to the x dx is dv, e to the x is v. And then u times v, this is our integral I. It's equal to u times v minus integral v times du. U we found as sine x, v we found as e to the x, minus integral v is e to the x, du is cosine x dx. Then we call this j because we have to work on this again. We apply integration by parts to j here. So which one is u? Again the same. This is dv and the rest is u. U is cosine, du is negative sine dx. Okay, the derivative. And e to the x dx is equal to dv. What's the antiderivative of e to the x? It is e to the x. So v is e to the x. So I found v, u, and du. Okay, and then I go down. This is my j, u times v minus v times d, integral v times du. Cosine, u is cosine, v is e to the x, minus integral e to the x times du is negative sine x dx. Look, j is equal to e to the x cosine plus e to the x sine dx. But this is familiar, this is what we have started first with. Okay, this is the same thing. So, in other words, when we apply integration by parts second time, these trigonometric functions can give you what you have started at the beginning. Okay. Okay, so as you will see, j is e to the x cosine x plus I. So which is this? This is really good. So in other words, I is equal to sine e to the x. But we also knew that I is equal to sine x e to the x minus j. We want to combine these two, double star and star, and we get I is equal to sine x e to the x minus, instead of j we write that, and we have negative I. We take this negative I as positive on the left hand side. 2i is equal to this, so our answer, we factor out e to the x, which is common factor. I is equal to 1 over 2 e to the x sine x minus cosine. That's the final answer. And then we also quickly talked about the trigonometric integrals. I want to talk about this here again. Integral tangent x dx, we take it as a fact actually. Tangent x dx is equal to natural log absolute value of secant x plus c. We don't show why this is so, but actually there is an easy way to show it. We just skip that, and we take this as a fact as well. Integral secant x dx is equal to natural log absolute value secant x plus tangent x plus c. Now I want to do two examples. What is tangent cubed x dx, the integral of that, and what is integral secant cubed x dx? We want to do these two. Okay, so these are given facts, and we want to find the following integral these two, and we should recall that tan squared x is equal to secant squared x minus 1, cotangent squared x is equal to cosecant squared x minus 1, and I is equal to integral tan cube x dx, tan x times tan squared x dx, and integral we just separated into two pieces like that, and then tan squared is secant squared minus 1, as you would know. We distribute this over tan x secant squared x dx minus tan x dx. This one is known, which is up here. This is already known, but the other one, this one is by substitution, because we know, let's call this j. Look, this part is called j. I is equal to j minus this. This was already known. Okay, and u is equal to tan, du is equal to secant squared x dx, and j is equal to u times du then, because we have u and this is du, and the integral is u squared over 2 plus c1. But what is u? U is tan x, so we put it in, and we get the answer as tan squared over 2 plus c1. But we are interested in I is equal to j minus integral tan x. J we found, which is this, minus this antiderivative of this is ln absolute value of secant x plus c1 is the final answer. How about this one? Integral secant cube x dx, we separated into two like that as well. Secant squared x, secant x dx, integral of that. Integration by parts would work. So we are going to say u for secant x and du for secant squared x dx. U is secant x, du is secant x tangent x dx. Secant squared x dx is equal to dv, tangent x is v, and then we just put it in. This is our I, separated like these two, and this is equal to, by integration by parts, u times v minus integral v times du. U is secant x, v is tangent x, minus integral tangent x. What is du? Is secant x tangent x, as you would see here. Du is secant x tangent x. We put it in. See, u is secant x, we put it in. V is tangent x, we put it in. V times du, v is tan x, we put it in. Du is secant x tangent x dx. And we call this j. Okay, so far our result is I is equal to secant times tangent minus j. But we need to find j. What is j? J is integral tan squared times secant times dx. Remember, tangent squared is secant squared x minus 1. Okay, if we put it in, we get secant cube x minus secant x, but this is I that we started with. So j is actually I minus integral secant x dx, but integral secant x dx is known. J is equal to I minus ln absolute value secant x plus tangent x plus c1. Next we combine these star and double star. I is equal to secant tangent minus I plus ln secant x plus tangent x plus c1. Take this I to the left side and divide everything by 2. You get the I is equal to this. That's the final answer. Okay. Then trigonometric substitutions. Let me see. Okay, So this is the section trigonometric substitutions. Probably I should do this in a separate video.